So next we have the definition of walk. So here definition of walk. The walk means it is a alternative sequence of vertices and the edges. Okay, walk means the walk is defined as a finite alternating sequence of vertices and edges, beginning and ending with the vertex. Okay, the sequence is beginning start with vertex and end with the vertex. Okay. Now, in this walk, in this sequence, the edge appear only once. We are not repeating the edge. Okay. In this walk, we consider here the edge is repeated, is not repeated. It is comes only once, and vertex may be repeated. Okay. Also, if we have the first vertex and last vertex, both are equal, then it is called closed walk. Okay. And the number of edges which are included in a walk, it is called length of the walk. Now see, this example here. See, in this graph, if we consider here, if we start with the A here, okay, and we start the write the sequence A, then E1, B, then E2, C, then E3, D, then E4, E. Okay, then this is called a walk. Okay, first we start with the vertex. Okay, then we have edge, then again vertex, then edge, then vertex, then again edge, then vertex, then edge, and then vertex. So here we have taken the every edge only one time. Okay, so this is called walk. Okay, now here one more walk is given. That is it is starting from, it is start from the E, then E8, E again, okay, E8, E, then E4, D, then E6, B, then E1, A, okay. Then if you take here E7 and you can come here E again, okay. Then also you can go for E5 and B. You can repeat the vertices, but you cannot repeat the edge here. Okay. So I have repeated the E 3 times, B 2 times, but I am not repeating here edges. Okay. So if you repeat the vertex, it is okay in a walk, but you cannot repeat the edges. Now this is given a definition in our reference book, Nursing DO, but in some books, in other book of graph theory, in some books they are giving a definition, walk only the alternative sequence of the vertices and edges. That means they are saying that in a walk you can repeat the edges also. Okay, and they define the one more term, tail. In a tail, they are saying that in tail you cannot repeat the edges. Okay, in some book of graph theory, they define the three terms here: walk, tail, and then path. In our book, in our reference book, Nursing DO, there we have just two terms, walk and path. Okay, so here in walk, we are consider that we are not repeating the ages. Okay. Now one more thing here. Say you cannot take the work like in work. The when you take the age, then the before the age, the vertex, it is a one endpoint of the age, and after that age, the vertex, it is a second endpoint of that age. You cannot take sequence like this, that here A, just wait. Here, here from A to here B, okay, A, then E1, B, then E4, D. You cannot write this way. A, E1, B, then E4, D. That is not an alternative sequence, because at B, we have incident ages are E5, E6, E2. So you have to take the either E5, E6 or E2. Here E4 is not incident on B. So you cannot take E4 here, okay, after B. So alternative sequence of vertex and age, starting with the vertex and ending with the vertex. But remember that the every age covered by its two endpoints. The before the age, a vertex is the endpoint of that age, and after the age, the vertex is the endpoint of that age. Okay. Now see here, the third one is given that here A, E1, B, then E5, E, then E8, E, then E7, A, then E1, B, then E2, C. It is not work. Why it is not work? Why it is not work? Because
Age is repeating.
yes, E1 is a repeated. So we define the work by that alternative sequence of vertex and edges where the we can repeat the vertices, but we are not repeat edges. Okay, so this is a work. Okay, when it is called work is called close. When we say that the work is a close, if we have the first vertex and end vertex, both are same. Like here, if we start with the A and if we end with a, the work, then it is called close work. Here we have one length close work also. Look, you start with the E, then E8, then again E. So it is a close work with a length 1. You use the 1, 8. Say in our first work here, we have A, then E1, B, then E2, then C, then E3, D, E4, E. This is a open walk. It is not complete. Okay? So it is a open walk. So in it has a length is a E1, E2, E3, E4. 4 edges are used. So it has a length. It has length 4. Now if we add here E, then we write the E7 age and then A. Okay? We start with the A and we end with the A. That here we start with A to B, E1, then E2, C, then E3, D, then E4, E, then E7, A. Then this is a close walk. Okay, this becomes close walk because we start with the A and we end with the A. Okay, this one is called close walk. Now we define the next. Next we have, say here close walk is given this A, E1, B, E2, C, E3, D, E4, E, E7 and A. These are close walk. Okay. Now next we have definition of path. Okay. So open walk, which in open walk if we are not repeating any vertex, then that open walk is called path. Yes, an open walk in which no vertex appear more than once is called path. Okay. The number of edges in a path is called length of path. Okay. Here we are not include the self loop, because if we include the self loop, we repeat the vertex. Okay. In a graph, if here we take the E, then E8, then again we reach E. So it becomes the closed walk or closed path. Closed path, it is defined it is defined a circuit. Okay, it is not called path. So path means an open walk in which no vertex appear more than once. So in here the first walk we have taken A, E1, B, E2, C, E3, D, E4, E. This is a path from A to E. Okay, it is a path from A to E with a length 1, 2, 3 and 4 length. It has a length 4. We have another path from A to E. It is A to A, E1, B, then E5, E. So it is a one more path from A to E with a length 2 only. Okay. Then one more path we have A to E7, then E. It is also a path, okay, with length 1. Okay, because one edge is included. It has a length 1. Now can you find the path from A to E with length 4? मैंने जितने पाथ कहे उसके अलावा और एक पाथ आपको फाइंड करना है विथ लेंथ 4 फ्रॉम ए टू ई. हेलो हेलो. You can write the answer in a chat box. Write in chat box which paths have a full length from A to E. Simple है. A, E1, B, E6, D, E4. So E1, E6, sorry, it has only length 3, not 4. It is length 3. So length 4 path is only this one. A, E1, B, E2, E3, D, E4. This is only one path of length 4. Okay, then we have length 3, length 2 and length 1 path. Okay, so we have these are the paths from A to E. Okay, here given a first one is a path from A to E. Now in second, see, E is repeated. So it is not a path. It is walk only. Okay. Then in third one, we have A E1, B E2, C E3, then D E6, B. So here also B is repeated. So it is also not a path. It is only walk. Okay. So when we have the walk, in walk, if edges are appear only one time, then that walk is called path. Okay. And what is the walk? Walk is the alternative sequence of edges and vertices and edges, starting with vertices and ending with vertices. Okay. Now next we have definition of circuit. Now what is a circuit? So here circuit means a closed walk in which no vertex appear more than once is called circuit. Now it is closed, that means the first and last vertex are same. So they are same, but excepting the first and last vertex, the between vertex are not repeated. Okay. So if we eliminate the last vertex and last edge, then the remaining portion is to become path. Okay. The remaining portion is a path. Then if we add the last edge and vertex, it becomes circuit. Okay. So here, now here, which is a circuit? So here first we take the circuit of length 1. Here see, this is a starting with a E and ending with E with a edge E8. So E8 E. It is a circuit with length 1 because their edge is a 1. The another circuit we have A E1B E5E then E7A. Okay, this is a circuit from A to A with length 3. Here we have 3 edges, so it has a length 3. Then here you have one more circuit from E to E, A to B by E5, then B to E C by E2, then C to D by E3, then D to E again by E4. So this is also a circuit from E to E with a length 4 because here we have 4 edges are used. Okay. So circuit means a closed walk in which no vertex except the first and last vertex appears more than once. Okay. See here examples are given. We have A, E1, B, E5, E, E7, A. Then B, E6, this B, E6, D, E4, E, then E5, B. These are circuits. It is also called cycle. In some books, they are defining the circuit as a, they saying cycle. So both are same meaning, circuit or cycle. Okay. Now here we take, this is a two example of the circuit. The both are the two regular graphs. These two are two regular graphs. Say here you can find the closed cycle, okay, closed walk, sorry, closed walk. Here also we have a closed walk. So these two are example of cycle. Now see here, from this two, you can write that, you can note that the one point, that the inner circuit, if we have the circuit, then every vertex of the circuit have a degree 2. In a circuit, the every vertex have degree 2. Okay? It have a more than 2 degree in a graph, but when we draw the circuit only, then in that circuit, the every vertex have a degree 2. Okay? Now we have connected graph and disconnected graph. So what is a connected graph and what is disconnected graph? So connected graph means a graph is said to be connected if there is at least one path between every pair of two vertices, every pair of the vertices in G. If there exists two vertices in a graph G such that there is no path between that two vertices, then that graph is called disconnected. Okay? So connected means you can find at least one path between any two vertices of the graph. Yes, like say in a first graph here, this is a graph with 6 vertices. Here, if you want to find the path between any two vertices, you can get. Okay, you can get from A to D. Here, say A to D are connected. If we want to find path between B and E, then we can find the path here from B to E, B, G, C, H, D, I, E. Or you can find the B, F, A, L, D, I, E. Okay, you can find this way also. So here you have a path between any two vertices. So this graph is called connected graph. Now consider this whole graph. This rectangle, this straight line and this dot. This three, the combination of these three is a one graph. So from this one graph, now here there is a no path between N and I. Okay, there is no path between M and I. Also L and I. Also K is not connected with any vertex. So this graph is called disconnected graph. Okay, this is a disconnected graph. In previously, when we give the example of isolated vertex, at that time also we use the disconnected graph. Okay, the example of isolated vertex and pendant vertex. In that time also we use the disconnected graph. Okay, so this graph is called disconnected graph because the K is not joined with any vertex by any path. Okay, so if you get the at least one path between any two vertex of the graph, then that graph is called connected graph. If you are not getting the path between two vertices of the graph, then it is called disconnected graph. Okay. Now here, first we take the one example exercise over a walk, path and circuit. Okay. So here you have to find the possible walk, path, and circuit. Okay. Here all of you have to write one walk, one path, and one circuit in a chat box. See, the vertices are denoted by capital A, B, and C. The edges are denoted by here C, H, F, and G. Okay. So everyone have to write the one walk, one path, and one circuit in chat box. Write down. यह सिंपल है, बहुत जल्दी हो जाएगा. अभी तक एक भी चैट बॉक्स में मैसेज नहीं है. हेलो. What happened? Write answer in a chat box. Yes, Smith. Smith A B C A. It is a circuit. Okay. Just write the ages also. Yes, walk A F B G C H A. It is not only walk puja, it is also a circuit. Okay. A C C. Ritesh, you have repeat the age in a walk. You cannot repeat the age. You can repeat the vertices. So you can write walk is A C A small c, then capital C, then H A, then F B. Okay, this is a walk where we repeat the vertex A. Okay, you cannot repeat the age. So just Ritesh, correct your walk, change your walk. Path is a right, and so you have write the path AH AHCGB AHCG, then GB. It is the right path. Then circuit is also right. Okay. Krishna. Yes. Okay. Now, write one walk of length one walk with length 3, 4, 5. With length 5 from A to C. Write one walk in a second graph. You have to write the one walk from A to C of length 5. 5 लेंथ की एक वॉक बनानी है A से C की. 5 length means you have to use the 5 vertices, 5 edges. इस बार हिनल का भी आंसर आया है. वेरी गुड. अभी वानी और ईशा, इन दोनों का आंसर नहीं आ रहा है, ये तीसरा ले लो। In the second graph, you have to make a one walk from A to C of length 5. So this is a walk, so you can repeat the vertices, okay? But I'm saying that walk from A to C, so you have to start with A and you have to end with a C, okay? You can repeat the C one or two times. Smith, A, E1, B, E4, D, then Smith, you have and work at the E5. E5 is a 8. They are saying that the walk is a alternative sequence of vertex and edges, starting with the vertex and ending with the vertex. Okay. So after E5, you will reach at again A. It is not walk from A to A. I want to walk from A to C. Okay. Smith, Ritesh, Ritesh. A, E1, B, E4, E3, E6, C. Okay. This walk is right, but you have used the only is right, but I want length 5.
Sir, but loop equals to
E4,
2
B.
edge length.
No, loop is a one edge. It when we count degree, we count two times. That it is a of length. And horse also same answer. Horse, horse is the right answer. Then you use the only four edges, so it is a sorry, Krishna. So it has a length 4. See, here, if you take this walk, A to C by E5, then by E6, again C, then E3, D, then E4B, then E2, C. Then here C, 1, 2, 3, 4, and 5 edges are used. We start with A and we end with C. So it is a walk from A to C using 5 edges. So it has a length 5. Okay. Understand? Now, in a second graph, you have to find the one path between A to B of length 3. One path between A to B of length 3. And write that in a chat box. Write answer in chat box. One path between A to D of length 3. E1D. Okay, Pranav. Yes, Pranav have a right answer. E5, E2, E4. Then Pooja, E5, E3. Pooja, you have write the path between A to B. I am saying A to D of length 3. Okay, Pooja, you have to write the path between A to D of length 3. Or E5. You repeat the vertex C. The vertex C, it is not a path, it becomes walk. Okay, so you have write the walk between A to. There is not E. E is a isolated vertex. It is not connected with C. What happened? Uh, of length, you can take one path A to E5 C, then E to B, then E4 D. Okay, this is a length 3. Then also you can use this one A to E1 B, then E2 C, then again E3 D. Okay, this is also length. This one has a length. This is also length of 3. Okay. Now, see this second graph, it is a disconnected graph. The first graph is a connected graph. Here, in a second graph, the 4 vertices are connected A, B, C, and D. But one vertex E, it is not connected to the any other vertex. So this graph is a disconnected graph. Okay. Now in this graph, first write the one walk, close walk from A to A, a close walk from A to A of the length 7. Of the length 7. Write one close walk from A to A of length 7. Give the answer in checkbox. A close walk from A to A with length 7. Length 7 means you have to use the all edges. So you can take here A to B, B to C, C to E, E to F, F to C, C to D, D to A. This is a closed walk from A to A. Now, can we say that it is a circuit? It is closed walk. So can we say that it is a circuit? Like yes or no in a chat box. Can we say that it is a circuit? Hello? Hello? साफ सुन गया Just you have to write yes or no. It is a circuit or not.
सर आंसर
I have
लिखा
given
है
you.
सर
I
चैट
don't
बॉक्स
know.
पे चेक करो।
अरे अरे जब नहीं है दूसरी अच्छा હવે અપડેટ છે sorry yeah
नेट
okay
प्रॉब्लम है
it is
सर
not a circuit because the vertex C it is a repeated okay from A to we go B then C then we go E then F then again we reach at C. So here C is repeated, so it is not a circuit. Now if we find the closed walk from A to A of length 4 by A to B, B to C, C to D, D to A, then this is a circuit of length 4. Okay, this becomes circuit of length 4. And here you have a circuit of length 3 from C to C, C to E, E to F, F to C. Okay, so this is a circuit of length 3. So I think now all have clear with a walk, path and circuit. The walk means alternative sequence of the vertices and edges. It is starting with a vertex, ending with a vertex. Okay. Then in a walk, if vertices are not repeated, then that walk is called path. And the circuit, a closed walk. In a closed walk, the excepting the first and last vertex, the no vertex are repeated, then that closed walk is called circuit. Okay. Now we have discussed in our first lab, we discussed about the Euler, that mathematician. He have a one problem that he want to find the one walk. There is a 4 places, the 4 places are joined by the 7 bridge. You want to find the one walk from one place, means close walk, such way that the every bridge will contain only once in a walk, right? So the same, that type of the walk, it is called the Euler line. And the graph which contains the Euler line, it is called Euler graph. So first we define the Euler line. So what is the Euler line? In a graph G, if possible, to find a closed walk running through every edges of G exactly once, then such walk is called Euler line. Okay? Here we find the one walk which contains the all edges of the graph, then that closed walk is called the Euler line. Okay? And if graph contains this Euler line, then that graph is also called Euler graph. Like in this graph. Here, if we start with A, then A to B, B to C, C to A. We get this closed walk. So this graph is called Euler graph. Okay. Then say in a previous slide, the last graph here. In last graph, here also we have, this is a Euler graph because we can find the closed walk from A to A. Okay, A, E1, B, E2, C, E5, E, E7, F, E6, C, E3, D, E4, A. This is a closed walk from A to A, which contain the all edges of the graph. So it is a called Euler graph. Okay, this is also called Euler graph. Now consider your first graph. Say your first graph. If we want to find the Euler line, if we start with A, we want to complete with A by containing all edges. So if we start with A, then A, C, capital C, G, F, A. We start with A, we complete with A, but we cover this 3 edges, we cannot cover this edge. Okay. Now if we take this edge and then G and then F, then we cannot cover the edge C here. Okay. So in any case, if you find here a closed walk, then it contains maximum 3 edges. It not contain the 4th one edge. Okay. So this graph is not called Euler graph because this graph does not have Euler line. Okay. This is Euler graph. Similar way here also, if we want to find the one closed walk which contain the all vertices, then here if we go with this A, C, then by E6, C again, then E3, D, E4, B, then E1, A, then E2 is the remaining. If we want to cover the E2, then we cannot repeat here E5, so we cannot reach again A. Okay. So if you find the walk in this graph, then we cannot get the closed walk which contain the all edges. So this is also not a Euler graph. Okay. So the Euler graph means a graph which contain a walk with all edges. Okay. The walk which contain all edges. Okay. See here we have one more example. Now here find the Euler line. Just write the Euler line in a chat box. Write Euler line in chat box. Euler line means a walk, closed walk, which contains the all edges. Okay. You have to start with A, then you have to reach at A again. Which is E5, E3, E2, E5, B के बाद E7 लिखना है, E5 नहीं, E7, E4, E6, B, E1, A. Okay, right. Good. So here we have there you have in this way also A, E1B, then E2, C, then E3, D, then E4, E, then E7, B, then E6, D, then E5, A. Okay, so this is a Euler line. Okay, in other words, you can say that a graph which we can draw जो ग्राफ हम बिना पेन उठाए ड्रॉ कर सकते हैं, ठीक है, डायरेक्टली, उस ग्राफ को हम ऑयलर ग्राफ बोलते हैं. ठीक है, यहाँ पे आपको पेन उठाने की जरूरत नहीं, पूरा ग्राफ आप डायरेक्टली ड्रॉ कर सकते हो. तो दिस ग्राफ इज कॉल्ड ऑयलर ग्राफ. Yes, here this is a Euler line. Okay. Now one more graph, this one. इससे पहले जब 7 एजेस थी तब तो ये ऑयलर हो गया था. अब 8 एजेस है तो ऑयलर होगा कि नहीं चेक करो. ये ग्राफ हम ऑलरेडी चेक कर चुके हैं विदाउट E8. Okay, if we eliminate E8 then it is a Euler graph. Yes, it is not Euler graph. because when you draw the any Euler line, means any closed walk, then at least one edge will remain. It is not Euler graph. Okay. Now here we have uh, one theorem here, which we are just we have the statement only, that theorem. We are not proving this theorem. But see, if you want to check the given graph is a Euler graph, then you have to check that the degree of all vertices. If degree of all vertices of the graph is a even, then it is a Euler graph. If there is a vertex with odd degree, then that graph is not Euler graph. Say in this graph, A is a even, C is even, E is even, F is even. But B and D are not even vertex. They have a degree 3. Okay. If we eliminate this edge, E 8, then B has a degree 2, D has degree 2, so it is a even. So we get the Euler graph. Okay. So if the degree of all vertices are even, then the graph is Euler. Okay. See, now we have Hamiltonian graph. Okay. So for Hamiltonian graph, in a Euler graph, we find the closed walk which contains the all edges. In Hamiltonian graph, we find the circuit which contains the all vertices of the graph. Then that graph is called the Hamiltonian graph. Okay. If we have a circuit in a graph which contains the all vertices, then that graph is called Hamiltonian graph. Like this one. Here, if we find the circuit A, E1, B, E2, C, E3, D, E4, A, then this circuit contains the, sorry, not that circuit, this circuit is contained only 4 vertices, the 5th one is remaining. So, if we find the circuit here, A, E1B, then E2C, then E3D, then E5E, then E7A. Then this circuit contains all vertices of the graph. So this graph is called Hamiltonian graph. Okay, this vertex, this circuit contains all vertices of the graph. So it is called Hamiltonian graph. Now here we have A has a odd degree, E has a odd degree, D and D. This all 4 vertex have a odd degree. It is not a Euler graph. Okay, there is no closed walk is exists which contain the all edges. So Hamiltonian graph means a circuit which contains all vertices. That circuit is called Hamiltonian graph. Okay, sorry, that graph contains this type of circuit. It is called Hamiltonian graph. Okay. See this graph here. Here, if we want to find the circuit, then if we start with a C, E2A, E1, B, E3, C, then we cover the only 3 vertices. The 2 vertices are remain. If we start with this edge, then also A and B are not included in a circuit. See here, there is the circuit is not exist which contain the all 5 vertices. So this graph is not a Hamiltonian graph. But see, all vertex have a even degree. It is a Euler graph. If you start with a C or A, if you start with a A, then A, E1, B, E3, C, E4, D, E5, E, E6, C, E2, A again. So it is a closed box which contains the all edges, but there is no circuit which contains all vertices. So it is a Euler graph, not Hamiltonian graph. Okay. Then we have the definition of Hamiltonian path. What is the Hamiltonian path? So if we have the Hamiltonian circuit, that is a one circuit which contains the all vertices, then if we delete the last vertex, okay, if we delete the last vertex, then we get the path. That path is called Hamiltonian path. Okay. If we have the n vertices, then Hamiltonian path have length n minus 1 because the n vertices are connected by the n minus 1 edges. Okay. Now here, find the Hamiltonian circuit first. Write the answer in chat box. Find Hamiltonian circuit here. This is a K5 complete graph with 5 vertices. So here you have the one circuit is A, E1, B, E2, C, E3, D, E4, E, E5, A. Okay. One circuit is this one, which contains the all vertices. See, for Hamiltonian, we have the condition over a vertices that we have a circuit which contains all vertices. There is no condition for edges that there is no condition that the vertex circuit contains the every edges. Okay. The condition is only a circuit which contains all vertices. That circuit is called Hamiltonian circuit and the graph is called Hamiltonian graph. So this is a Hamiltonian circuit. Now if we want to find the Euler line, that is the, we consider here blue color. If we want the Euler line, so we want a closed box which contains the all edges. So here from A to B, E1, then B to C, E2, then C to D, E3, then D to E, E4, then we use this E10 from B again, then here D, then again if we go there, okay, from A, then A to C, then C to E, and then again A. So we get this closed box. Okay. So this crosswalk we get A to A, E1, B, E2, C, E3, D, E4, E, then E10, B, E8, D, then E7, A, then E6, C, then E9, E, then E5, A. This closewalk contains every word edges, so it is called Euler line. So this graph is a Euler graph as well as Hamiltonian graph. Okay, this is a Euler graph and Hamiltonian graph. Okay. Now we have one graph which is called Peterson graph. This one. This graph is called Peterson graph. Okay. Sometimes
Peterson.
this Peterson graph, it is also asked in a 1 mark question, in a question 1B, that draw the Peterson graph or define Peterson graph. In definition, you have to draw this graph. That this graph is called Peterson graph. Many students are writing, if the question is asked that define the Peterson graph. So many students are writing that the graph which is not Hamiltonian graph is called Peterson graph. That is wrong. This is the property is given that this is a Peterson graph and it is not Hamiltonian graph. Because if you go for a circuit which contains all vertices, then you are not getting that circuit. Okay? Like if you start with A, then A to B, B to C, C to D, D to E, E to H, H to I to J, J to F, F to G, then again you get H. But in circuit, we cannot repeat the vertex. Yes, so we cannot reach A here again without repeating the vertex. So it is not Hamiltonian graph. This graph is called Peterson graph and it has a property that it is not Hamiltonian graph. Okay. So if the question is define the Peterson graph, you have to draw this graph. You have to write this graph is called Peterson graph. Yes.